All right, guys, this is lesson 2.4. This is our last, so part 3. So our last and final video on this one. Another problem just like the one above it. So not a lot different going on here, but just one more to practice it. So they give us two sides. Again, we know angle C is a right angle, but two sides. And so we're going to need our inverse trig functions because we're looking for some angles here. Okay, we can sketch this out just so we have a reference point over here. So let's just quick get a little sketch here of a right triangle. There's angle C. Here's angle A, here's angle B. Side C is 647, that's our hypotenuse, so always side C is our hypotenuse, 647. Side B is 219. So very similar problem to the previous one. All right, let's get side A. Let's go Pythagorean theorem. So I've got A squared, I've got my 219 squared, and that's going to equal 647 squared. All right, Pythagorean theorem. Let's use a calculator for that. Clear that out of here. We'll go 647 squared. We'll take off the 219 squared. Got this answer. And now let's don't forget the square root. So second square root of our answer. Oops, didn't really need that parenthesis there, did I? So square root. And we get a 609 for side A. So let's keep track of that. So side A is 609. Okay, just like our 609, just like our previous example, let's try to use the things that we've already calculated. Oh, I'm sorry, not the things we calculated, the things we've been given. So we've been given 219, we've been given 647. Let's this time, well, let's find angle A again. So it looks like the cosine again. So step 2 here, we're going to get the cosine of A is the adjacent side, 219, and it's over the hypotenuse, 647. Guys, I'm looking for an angle. When you find yourself looking for an angle, that's when you use the inverse trig functions. So we're going to go cosine inverse again. So that's second cosine. I'll put the fraction right in there. It was 219. It was divided by 647. There we go. 70.2. We'll just talk about checking these answers a little bit also. But we've got angle A is 70.2. And then because we know it's a right triangle, angle B is 90 minus 70.2. Check that out and see if you don't get 19.8 degrees. Okay, one little check you can do anytime you solve a triangle, it doesn't catch all your mistakes, but it'll catch some of them, is you know in a triangle we have 3 sides. We have side C, we have side B, and we just found out side A. Well, in a triangle it works. The biggest angle will always go with the biggest side. So our biggest side, right here, side C, angle C, remember, that's the 90-degree angle. That was our biggest angle. The smallest side, right here, it was side B, always goes with the smallest angle. And our medium side, which was side A, goes with the medium angle. If ever it doesn't work out that way, you've got a mistake in your problem somewhere. All right, last problem. And it's the same thing, we're solving triangles, except the nice thing about word problems is, usually you're not solving a whole triangle, you're finding just one part of the triangle. So that makes it a little bit nicer. And the book will give you problems with angles of elevation and angles of depression. And what this means is you've got some kind of a scenario, somebody, whatever, here on the ground, and maybe there's, I don't know, sometimes like a hot air balloon or something like that up in the air. And what's going to happen is you're on the ground, you're looking up at the hot air balloon. And the angle of elevation, if you're looking up, that's elevation, depression is looking down. The angle of elevation is always measured with the horizontal. So it's this angle right here. So you go from the horizontal, how much are you looking up? You're looking up at a hot air balloon, or you're looking up at a water tower, looking up at the sun, or something like that. Okay, the thing to realize though, and this will be somewhat important, is imagine there's somebody in the hot air balloon looking down at you. Well, if they're looking down, that's not elevation, that's depression. but it's still measured with the horizontal. So from this guy's perspective, we have to sketch in a different horizontal line. And the angle of depression is measured from the horizontal, so it's this angle right here from the horizontal. How much are you looking down? And now you might look at this and realize, wait, this first line and the second line you drew are parallel. I just cut it by a transversal right there. The alternate interior angles are equal. So an angle of elevation is the same thing as an angle of depression, which makes sense. If you're looking at somebody in a hot air balloon and you have to, raise your eyes 20 degrees or whatever, your angle of elevation is 20 degrees, the guy in a hot air balloon looking down at you, his or her angle of depression is also 20 degrees. So that's one thing that's kind of nice to know. Okay, let's try one of these problems, and that will take care of this section. So the angle of elevation of the sun is 23.4 degrees. Find the length of a shadow of a person who's 5 feet 9 inches. Okay, so we need the ground here. There we go. We need the sun. I don't have yellow, so we're going to have to settle for red. Okay, then we have a person standing who's 5 feet 9 inches. And I'm not going to draw a person, I'm just going to draw a line. Okay? And we're going to look, okay, and we know the angle of elevation is 23.4 degrees. Sorry, I had to hesitate there for a second. And you know, when the sun shines, light travels in straight lines. So the sun's going to come down in a straight line, and it's going to hit the top of his head. Anything that comes down below this guy's head is going to get blocked. Anything above it will be light. And so what you have behind the guy, right in here, is a certain area that gets blocked by the guy so that it won't receive sunlight, and that's the guy's shadow. All right, and so the question is, can we find the length of this shadow? And the answer is yes. If we could just come up with the right triangle, if we could find 3 things in the right triangle, we could find this guy's shadow. So let's draw this line right here, and I think I see a triangle. I think I see a right angle. I wish I could label 2 more things in this triangle. Oh wait, the guy's height, right there, 5 feet, 9 inches. I know in a foot there are 12 inches, so 5 times 12 is 60. So check this out, but 5 feet 9 inches is the same thing as 69 inches, just so we have common units, so we don't mix feet and inches together. So there's one more thing. And then the angle of elevation, look guys, from the horizontal up, that angle right there is 23.4 degrees. Okay, we can solve this triangle. Good news is they only want one thing. And what do they want? The length of the shadow. That's this part right here. So what am I given? I'm given 5 feet 9 inches. I'm given this angle. So I'm given the side opposite the angle. I want the side adjacent to the angle. Which trig function has opposite and adjacent in it? You're right, tangent. So I'll go tangent of 23.4. Good news, I don't need inverse trig functions. Is the opposite 69 inches over the adjacent, which I don't know. Okay, you would have practiced this in the first video, but when I have something like this with a variable on the bottom of the fraction, so it's down here in the bottom, I'll write this as a proportion. How do you solve proportions? You cross multiply. So 69 times 1 gives me 69. X times the tangent of 23.4 gives me x times the tangent of 23.4. Divide both sides by the tangent of 23.4. I get 69 divided by the tangent of 23.4 equals x. Not a real satisfying answer. Let's pull out our calculator and get a number for that. That'll be a little more satisfying. And again, I don't need an inverse. I'm just going to go 69 divided by tangent. I don't need an inverse because I know the angle, 23.4. And what do you think? Is that shadow going to be bigger or smaller than the person? That angle of elevation isn't real high. 23 degrees isn't real high in the sky. See what we get? Angle of elevation is 159 inches, or maybe we want that in feet. Let's divide it by 12. So it's 13¼ feet. So 159 inches or 13.3 feet. So x equals 159 inches or 13 feet. And that makes sense. When the sun is low in the sky, the shadows get very, very long. All right, that completes our third video. There will be other word problems on the homework, equally tricky. But like I say, you got an angle of elevation, angle of depression. They're really the same.